Okay, this lesson is on chapter 10 part 2 on histograms. Okay, so histograms are used to represent group data. Okay, so here to fill in the blanks, histogram. Okay, so data that are grouped together, we call them group data, and they are grouped with class intervals. I'll explain a little more on what class intervals are in a while. Okay, then the next sentence, histogram consists of rectangles whose areas are proportional to the frequency. So there are quite a number of new terms over here, but we'll go into detail what each of them mean. Okay, so there is a difference between bar graphs and histograms. Okay, pardon my diagram. There's some missing parts over here. Okay, so let me just answer the fill in the blanks for you. Now, there is a difference between a bar graph on the left and a histogram on the right, which is what we are learning. So in a bar graph, it has a set of vertical or horizontal bars or rectangles, and there is uniform spacing between each of the bars or rectangles. So over here there is some spacing. The height of each bar or rectangle is proportional to the frequency. So when the bars or rectangles they are standing up, when they are vertical, the height, all these heights, these values, they tell us the frequency. Okay, so for the first bar in January, it is, according to your notes, we've got a frequency of 21 cars. In February, which corresponds to this one, there's a frequency of 50. Then we have a frequency of 40 over here. Okay, so frequency simply means the number of times, in this case the number of cars, and the base of each rectangle has no meaning. Our bar graph looking like this, this is the base of the rectangle. How wide or how narrow it is doesn't matter. It doesn't tell us anything. Now let's compare with a histogram. The data over here is grouped into different class intervals. Okay, so according to our notes, the first class interval, the number of pads is from 0 to 2. The next class interval is from 2 to 4. Next class interval from 4 to 6, so on and so forth. We also note that there is no spacing between the different rectangles. This time the area of the rectangles are proportional to the frequency, and the base of each rectangle represents the class width. So over here we've got a class width of 2, class width of 2, class width of 2. Now we are going to construct a histogram of equal class intervals. That means the base of each rectangles will be the same. In this case, it is for group data with equal class intervals. Okay, so the time, here we have the time in minutes that 30 students spend doing homework. So obviously there should be 30 numbers over here for 30 students. Time taken in minutes from 0 until 20, but we do not include 20. So let's see how many there are. And as we go, we strike them off. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the frequency will be 11. So let's go on for 20 to not including 40. We've got 1, 2, 3, 4, 5, 6, 7, 8. Is there any that I missed out? Okay, so there should be 8. Okay, nope, there is one that I missed out. 35 over here. So there are 9. So we continue doing for the rest, and we'll see that frequency will be 8 and 2 for the rest. So just do a quick count, and we see that the total will be 30, which makes sense. Okay, so these are some of the terms used for the class interval. So the class interval is from, for example, greater than or equal to 2 but less than 4. So this is known as our class interval. Then we've got the upper class limit and the lower class limit. So lower class limit and the upper class limit. Then our class width is the upper class limit minus the lower class limit. So now we have to construct a histogram with equal class intervals to illustrate the data above. So we're going to have the vertical axis as our frequency and our horizontal axis as time. Okay, so these are my vertical and horizontal axis, vertical for the frequency and horizontal for the time in minutes. So now it is up to you how you want to what the scale is that you want to use. For the horizontal axis, it is quite straightforward. The time taken from 0 to 20, 20 to 40, 40 60, 60 to 80. So we can have 20 over here, 40, 60 and 80. And for the vertical axis, perhaps we can use 2, 4, 6, 8, this must be 10, and look at the highest frequency, we actually have 11. So 11 would be here. So now for the range of 0 to 20, we've got the highest frequency of 11. So using a ruler, draw a horizontal line. You must be using a ruler for this. So this is for our first class interval. Second class interval, 20 to 40, frequency is 9. So 9 will be here. Third class interval, frequency is 8. And the last class interval, frequency being 2. So now this is our histogram. So part C, describe the distribution of the time spent on homework by the 30 students. We can talk about the range. So range again is the same, largest value minus the smallest value. So range is okay, the distribution ranges. The distribution ranges from 0, that is didn't do homework, to 80 minutes. The modal class interval, again model class, meaning the highest frequency, in this case must be from 0 to 20, is 0. Be careful of your inequality sign. It is actually from 0 including the 0 to 20 but excluding 20. Okay, that's one way you can put it. Or we can say most of the students, they spend 0 to 20 minutes on homework. What else do we notice? There's a downward trend, right? So we can also say, last point, the distribution has a tail towards the lower values, meaning that the values get lower, the frequency gets lower and lower. Okay, now we are going to try to interpret and analyze data in a histogram. Here we have this histogram showing part of the masses of 120 adults, and the corresponding frequencies are given as follows. So from 40 to 50. Okay, from 40 to 50, that is this portion over here. The frequency is actually 16. Okay, let's read off over here. This is actually 16 as well. Okay, what about from 50 to 60? The frequency would therefore be 24. Continue reading off. We have 34. Then from 70 to 80, oh, there's a blank. Okay, never mind. From 80 to 90, we've got 18. Okay, so should we be putting a 0 over here, or should it be something else? Take note that this is for 120 adults. How many people do we have here currently? Let's count. 16 plus 24 plus 34 plus 18. That gives us 92 people. Remember that this histogram is supposed to have the masses of 120 adults. So currently we only have 92. That means the frequency for adults having a mass between 70 to 80 is actually 120 minus 92, which is 28. Okay, so there's a blank over there that we should include. You can include it if you want to. So that would be over here, 28. Okay, so we have completed the frequency table, and now we have completed the histogram. Write down the class width of the class intervals. Class width will be 10 kilograms equals to, you can just choose one of them because they're all supposed to be the same, and units are important. Find the percentage of adults whose masses are less than or equal to 60 kilograms. Less than or equal to 60 kilograms. From our histogram, we can tell that we require these adults. So that gives us 16 plus 24. That's the number of people. Then to convert it to a percentage, this is what we'll do. Percentage equals to 16 plus 24 divided by total number of people times 100% to give us 33 and 1/3%. Do not round off since it is exact. Next, write down the for part D, adults with mass more than X kilograms are considered overweight, and since they tell us that there are 46 adults who are overweight, we have to find out the value of X. So take note that we've got 18 adults over here, we've got 28 adults over here. That gives us a total of 46 adults already. Why am I counting from the back? Because the greater your weight, the more likely you are overweight. And they also mentioned that more than a certain value of x will be considered overweight. So we need to start from the back. This 18, definitely overweight. This 28, let's add them up, we get 46, and these are the 46 who are considered overweight. Okay, and there's a cutoff weight of 70 kilograms. So for our presentation wise, we can say that, based on our description, number of adults with weight, we saw it was 70 and above, right? Above 70, sorry, 70 and 90. So the number of adults with the weight in this range is 46. So these are the 46 who are overweight. So x must be equals to 70. Write down the model class interval, so that will be the highest, between 60 to 70. Now Jane says that the range of the masses is 50. Explain why she could be wrong. Why do you think she said it was 50? Most likely, she used the largest value, 90, minus the smallest value of 40 to arrive at 50. But you must remember, the range requires us to subtract the smallest number from the largest number. The smallest weight from the largest weight. Can we guarantee that there is a person whose weight or whose mass is 90 kilograms? Can we guarantee that the smallest mass is 40? We can't. This grouping forces anybody's weight that is between 80 to 90 to fall within this bar, the last bar over here. For all we know, the greatest mass could be 81, it could be 82, it could be 89, it could be 90, we don't know, because they're all lumped together. So it is not correct to be so sure that the range is 50. So she could be wrong. Okay, so we say that we do not know the exact values of the smallest and largest masses. So we cannot conclude that the range is 50 kilograms. Now, as part of your homework, I want you to complete exercise 3 by yourself. The next portion is misleading interpretation of bar graphs. So bar graphs, there is this little gap over here. Okay, let's take a look at this. An exercise for an article in the newspaper reported the number of crimes reduced by half from 1991 to 2001. And this is the bar chart that is used for the statistics. So why is this? Does this bar chart make sense to you? Take note that it says the number of crimes reduced by half from 1991 to 2001. Visually, does it look like there is a reduction in half? Obviously, there is according to the diagram, the graph for 2001 is much smaller than the graph for 1991. But if we were to compare the values, this is actually 1000 and the value over here is 500. So in fact, there is a reduction by half. But why is it that the graph looks so strange? The reason is because the horizontal axis over here has a value of 400. It didn't start from a frequency of 0. Remember, this is our frequency. If you look at all our histograms and bar charts so far, they always start with 0. Okay, over here this value is also 0. this is also 0. Likewise, this is 0. But in this case, it is 400. So that is the reason why it looks really strange, and we call it misleading. We say the bar graph or the bar chart does not start with a frequency of 0. Hence, the height of the bars are not proportional to the frequencies, which can be misleading. Okay, so if we want to correct this chart over here, we should start from 0. So this being 400, this must be 300, this over here 200, 100, and 0 over here. So if I want to correct it, this is what my graph will look like now. Now, does it look like there's a reduction by half? No, it does. Okay, now for the next segment, appropriate data representations. So we've got Ali and Sally who collect data on the heights of students in a class. So Ali is recording the heights using these intervals. 131 to 140, 141 to 150, so on and so forth. Whereas Sally records it using inequalities like this. So which way of writing the interval is a better representation and given a reason? Straight away we should be able to tell that there's a problem with the way Ali does it. What if I have a student whose height is 140.8 cm? Which interval does he fall into? Does he fall here? Or does he fall here? You see the 104.8 doesn't fall within the first group, it doesn't fall within the second group. However, if we were to consider the way Sally does it, we can tell that 104.8 fall within this class interval. Okay, so we can tell that the way Sally does it is better. So in words, we say that heights are heights of students, okay, of students is continuous, meaning we can have heights with decimals. They do not have to be integers only. Okay, we can have 104.0123, 105.005. It is continuous. It is not just whole numbers or integers. So using Ali's representation will not capture data of all heights. Example 104.8 cm. Therefore, Sally's representation is better. Okay, the last part. Ali wants to use a pie chart, whereas Sally wants to use a histogram to illustrate the results collected. Give a reason why a histogram is a better representation than a pie chart. Okay, so in a histogram, it is easier for us to read the frequencies, whereas if you are using a pie chart, you still need to make some calculations in order to find the frequencies by taking the angle divided by 360 degrees times the total frequency. Okay, so we say that it is easier to read frequencies of a histogram while it will take some calculations to find the frequencies of intervals from a pie chart. Okay, so the next one is just a summary. Histograms have are rectangles, consist of rectangles whose areas are proportional to the frequencies. The base of the rectangle represents the class width. Okay, so for histograms with equal class intervals, the height of the rectangles are proportional to the frequencies because the class intervals have equal class width. There are some histograms with unequal class intervals which we haven't seen yet in our notes so far. So for these kind of histograms, the class widths are different. Therefore, the heights of the rectangles are not proportional to the frequencies. Okay, but the areas of the rectangles are proportional to the frequencies. So right from the start, we mentioned that the areas are proportional to the frequency. Okay, we didn't mention anything about height. It's just that so far everything looks like height is proportional because we have been dealing with histograms with equal class width. Okay, so for histogram with unequal class intervals, we calculate the height of each rectangle using the frequency density. Okay, the word density, you should have come across it in your physics. Similar concept, it is a division. So our frequency density is given by frequency divided by the class width. Both terms you are familiar with. So moving on to exercise 6. This is the distribution of times taken by students to travel to school. 11 of the students took at least 5, but less than 10 minutes. So complete the table below. So the time taken from 0 to 5 minutes. Okay, that means we are looking at this over here. In order to find the number of students, we will need to take the value. We will need to take the value of the class width multiplied by the frequency density. Okay, so there are some missing numbers over here. This is actually 1, this over here is 2. Okay, so we've got this as 1.4, this being 2.2. Okay, so let's go back to our frequency density formula. If the frequency density, which is our vertical axis now, is given by frequency divided by class width, then the number of students, also known as the frequency, must be equals to class width multiplied by the frequency density. Okay, so this is important. Frequency is the class width multiplied by the frequency density. It is just another way of writing the frequency density. So now if I want a frequency, I simply take the class width, which is 5. This is my class width, multiplied by the frequency density of 1.4. So 1.4 times 5 will give me 7. Okay, let's do a check for the next one. Class width is 5 again. 5 multiplied by 2.2, we get 11, which is correct. And finally, the last one. This class width is very large. From 30 minus 10, got class width of 20. So 20 multiplied by 1, and we get 20, of course. Okay, so we have covered almost the whole of this set of notes. Your homework will be exercise number 3, due on 18 Jan during lesson. Okay, so that is the first one, and we've also got exercise 7, homework due 18 Jan on Friday. Exercise 8 as well, homework due 18 Jan. Likewise, for this homework, this is due after the weekend. Okay.